All right, geometric series, part one. Again, always show your work. All right, so what's our instruction set here? Determine if the sequence is geometric, arithmetic, or neither. If arithmetic or geometric, write the recursive rule. Notice I want the recursive rule. All right, so what's going on in number one? Of course, number one's got fractions, and I know that's rough. It'd be cool if it wasn't. It is not geometric. Like you could say, okay, a third times two is 2/3, but times two is one. No, it's addition. You are literally adding a third. 1/3 plus a third is 2/3. 2/3 plus a third would be 3/3, which is one. So it's arithmetic, okay? Now I'm going to plug into the recursive rule. First term, if n is 1, and the previous term plus the difference if n is bigger than 1. That's what I'm plugging into. I'm not doing anything special here. But anyways, the first term is 1/3. And again, all you'll notice is I just memorized things. If n is 1, and I am the previous term, which is called a sub n minus 1, plus that difference, which happened to be a third, if n is bigger than 1. So that one was arithmetic. It was. Might be the only one. I don't know. I'm not going to do all of them. All right, number 4 was picked. What is number 4? So, sadly, y'all are kind of bound by technology because your basic math is kind of bad. Your ratio is always second over first. And it had best equal third over second. And that had best equal fourth over third. These ratios need to be the same. Otherwise, it's not common. It has to be what's called a common ratio. So I can already see it. I can already tell you what we're doing is we're dividing by 2. That's what's happening. But, you may not see that. You might have to be a button pusher. But anyways, let's see here. Let's go to math, num n over d. We got 1 over 32. Sorry, I need to do 1 over 16. And I need to divide that by 1/32. And I said dividing by 2, didn't I? We're not. We're multiplying by 2. It's 2. Is that the same as an 1/8 divided by a 16th? Well, I'm about to check. By golly gee, wow, it is. And I guarantee you that it's the same as a 4th divided by an 1/8. So this one has a ratio of 2. So it is going to be geometric. I want the geometric rule. It looks a lot like this one. The geometric rule says I am the first term if n is 1, and on the previous term, a sub n minus 1, notice I got the subscript there, times r if n is bigger than 1. So for my recursive rule, I'm simply going to be 1/32 there if n is 1, and then the previous term called a sub n minus 1 times 2 if n is bigger than 1. You might see people write that twice a sub n minus 1 because it does look better. It does. It doesn't matter where multiplication happens, front or rear. It doesn't matter. It really doesn't. All right, moving on to the next set of instructions here. I don't have anything highlighted on 5 or 6, but it says write an explicit rule 2 ways. Hopefully I can remember to do that. For the nth term of the geometric sequence, then find the 10th term. So I have 7 selected, and 7 doesn't really give me a whole lot of stuff. The easiest way to do 7 is probably visually versus 10, which I'm going to do, which is going to be algebraically. But I'm going to do 7 visually. So I've got the 4th term given to me, and it's 500. And it says the ratio is 5. So if I wanted the 5th term, it'd be 2,500. So to move right, we multiply. To move left, we divide. So this would be 100, this would be 20, and this would be 4. I did that, and which rule do I want here? The explicit. I did that so that I can plug into this guy, the explicit geometric rule, which is the first term times the ratio raised to the n minus 1. So I needed that 4. That's what I needed. It's going to be 4 times a 5 to the n minus 1. That's one of them. I said write it two different ways, right? So the other way of doing this is to manipulate this like I've shown you. 5 to the n minus 1 is 5 to the n over 5 to the first. That makes perfect sense if you bothered to memorize this rule right here. If you hadn't bothered to memorize it, it's just more gibberish and nonsense. And this is on your end. You're not memorizing. Memorization is the foundation of all learning. You memorize before you can connect dots. It leads to comprehension. It doesn't automatically grant you comprehension. It leads to it. But anyways, I can rewrite this as 4 times 5 to the n over 5. And then I can just kind of link those two together. 4/5 of 5 to the n. I'm going to wrap that 5 in a set of parentheses. Just looks better that way. It's formal math. Certain ways we write things. 10 is not probably best done through that, although I tell you what, the algebra on 10 is pretty brutal. But I need to show it because you might need it for number 9. I feel like it's just a multiplication of 4. I think that's all it is. My mind is leading to saying that I'm going to multiply by 4. 162 times 4 be 648. That'd be the 5th term times 4. It's not a 4. Let's try a 3. I'm doing recursive here. Okay, it's actually a ratio of 3. But I want to show you the algebra. So I'm going to plug everything I have into the explicit rule. That a sub n is the first term times r raised to the n minus 1. Now, I happen to have 162 when n is 4. Think about 4 minus 1. So, r cubed. And I happen to have 4,374 when n is 7, and 7 minus 1 is 6. And I'm going to do algebra because you know you're in an algebra class, kids. You are. Let's see, what we're going to do is we're going to take this guy and we're going to divide out r cubed on both sides. And that's going to tell me that the first term is 162 over r cubed. I can put that right there all day long. So 4,374 is 162 over r cubed times r to the 6th. 4,374 equals r to the 6th over r cubed, you know, that's literally r cubed, is 162 r cubed. Divide out the 162, and I wish I could tell you what that was. If I wasn't so sleepy, I probably could. But I can still push buttons on a calculator. It's 27. And I'm glad it's 27. Because I know that the cubic root of 27 is 3. So there you go. I have r. I can take that and I can plug it right back in. This will tell me the first term is 162 over 27. And how many times 27 under 162? 6 times. So the first term is 6. So now I have all my pieces. I have the ratio, I have the first term. I'm plugging in again into a sub 1 times r to the n minus 1. So the nth term is a 6 because the first term is 6 times 3 to the n minus 1. Or the nth term is 6 times 3 to the n over 3. And you know as well as I do that 6 over 3 is 2. They both work. And they're both perfectly legit answers. They are. They're perfectly legit. They both generate the same exact sequence of numbers. Anyways, 9 is a little rougher than 10. And on 10, what I was kind of thinking in my head initially is I was thinking recursively because I'm tired and I don't feel like thinking explicitly, to be quite honest with you. But, you know, you can always fall back on just drawing this thing out and figuring out what you need. Like I know the 4th term is 162. 5, 6, and I get to the 7th term. and then 4374. And when I first glanced at it, I thought maybe it was a 4. Turns out it was a 3. And maybe you remember me talking about it, but it was a 3. I was pushing some buttons in the calculator. All right, moving forward, we have an evaluation. Evaluate the sum of the 3rd through 22nd term of the sequence generated by 3x plus 10. And it says if it looks like y equals mx plus b, it's arithmetic. Because it's arithmetic, you have to use the arithmetic summation formula. So it's not the one that I taught in class today. It's the one I taught Thursday the 12th. The sum of n terms is n over 2 times the first, in this case, the 3rd term, plus the 22nd term. Now, n is always high minus low. Add 1 back. That's an easy thing to do. Half your students will mess that up right there. But 22 minus 3 is 18. If you add 1 back, you get 19. So we're actually finding the sum of 19 things. It's 19 over 2. The first term happens when you feed this thing a 3. 3 times 3 is 9, plus 10, 19. The 22nd thing happens when you feed it a 22. 3 times 22 is 66. Add 10, 76. And then, we just do math. I'm just going to try to do as much as I can, even though I'm tired. 19 and 76, I feel like that's 95, right? I don't know how much farther I want to take this. To be honest with you, not a whole lot, but why not? I'm going to turn 19 over 2 into a 10, and then I'm going to take something away. But 10 times 95 is 950. But it actually wasn't 10, it was 9.5. So I'm going to take away half of 95. And half of 95 is 47.5. So 950 minus 47.5 is 902.5. And I'm exhausted, kids, so let's just check me. But this is how I would do that in my head. Ain't nothing special about me. It's really not. I promise you, if it's something I can do, you can do it too. 902.5. Ta-da! Of course, y'all don't care, so you'll just go straight to the calculator and push buttons. We all know that's true. 14, evaluate the series -3 plus 15 plus -75 plus 375 equals ... So meaning it continues forever. For n equals 10. This means find the sum of the first 10 terms and use your formula. Now, this thing is geometric. It has a ratio. We're multiplying by 5 as we move right. Because -3 times 5 is 15. 15 times 5, it's -5. Because -3 times -5 is positive 15. 15 times -5 is -75, and so forth. So your formula for your geometric, and this is geometric, so we got to use the right one. It says the sum of n things is the first term, big old set of parentheses, 1 minus, safe thing to put r in parentheses, to the n over 1 minus r. And it's a big deal on this one because your ratio is negative. So it definitely needs a set of parentheses. And then it depends also like whether the exponent's going to be even or odd. That would make the difference maker. This has 10 things. The first term's -3. 1 minus a -5, because that's the ratio, raised to the 10th power. And it's sitting pretty over 1 minus a -5. I don't know how much of this you want to do in your head. I don't know if you want to do any of it in your head or not. But, I would put a 6 there. That's what I would do. You don't have to, okay? So there's a -3. You got a set of parentheses. Math, num, n over d. 1 minus a -5. And that is raised to the 10th power. And if you don't know what 1 take away a -5 is, TI-84 don't judge. Now, the reason that parentheses was a big deal is if I didn't use it, I wouldn't get the same thing. Well, actually, I might get lucky on this one. Yeah. You see what happened? They matter. They do. But anyways, a positive 4,882,812. Hopefully I copied that down right. I don't feel like going back and double checking. Am I going to do anything else? Nah, that's it. Although I really should do like 26 because, you know, you can talk about my fifth period class. There's only 3 kids who can do it. It's really sad. Seventh, not a whole lot better, and to be honest with you. Like you two classes are just really, really giving up. It's not hard. F of g of x. Okay, so this is actually f of 4x minus 10, which means that every x in f becomes 4x minus 10. That's what it means. All it means. So here's an x. It becomes 4x minus 10. It has an exponent of 2 plus an 8. There's an x. It becomes 4x minus a 10. And then we have a minus 20. Now, everybody and their mama knows that if something's squared, you write it twice. Of course, everybody knows that, but they don't actually do it. Everybody also knows the distributive property. At least I hope you do. I have no idea how you got to be a junior in high school if you don't. But it happens. Some of your courses are rewarding you for cheating by putting so much of your grade into homework that you can pass and not know anything. Anyways, we're going to do the distributive property here. Or, you know, if you want, you can go off the side and do a box. Remember the box? I have 0 issues with the box. Not a single one. 16x squared minus 40x minus 40x and then plus 100. You do that box. If you like that box, do the box. Be the box. Nobody cares. Be the box. And then combine your like terms. So, you know, I saw that 16x squared, and the hundreds cancel each other out too, don't they? Choice B. Easy peasy, lemon squeezy. And hopefully that's the last bit of math I actually do today besides grading your quizzes.